Welcome to Engineering Physics. Let's discuss vectors. As discussed in your high school physics, two kinds of quantities are applied, scalars and vectors. Examples of scalar quantities are length, area, power, and speed. Vector examples include velocity, acceleration, and weight or force. As defined, scalars are quantities which can be described with just their magnitude or size. Vectors, on the other hand, are fully identified with both magnitude and direction. A vector can be noted with an arrow accent over the parameter or placed in bold letter. In the example of vector F equal to 30 kilonewtons north, 30 degrees west, 30 kilonewtons is the vector's magnitude, while north 30 degrees west is considered its direction. A vector is denoted by an arrow whereby the origin is known as tail or foot, and the arrow is considered its tip or head. The length of the arrow is its scaled magnitude. Regarding its inclination, there are two different ways to show the angle. One is by using the positive x-axis or due east, as it is where the first quadrant is located. The other is by measuring the angle from the close reference, either taking it from the x-axis or the y-axis. For example, you can denote the vector as 140 degrees from the positive x-axis, or either 40 degrees from the x-axis or 50 degrees from the y-axis. Vectors are categorized in different concepts. Collinear vectors lie on the same straight line irrespective of their magnitudes and direction. Parallel vectors have similar inclination, however they lie in two different paths. Coplanar vectors, on the other hand, occur on the same plane regardless of their direction, and concurrent vectors intersect each other or pass through the same point. The mathematical operations involved with vectors are addition, subtraction, and multiplication. Starting off with vector addition and subtraction, there are two methods. One is graphical method, which would require you to scale the magnitude and angle precisely. The combination of vectors or their resultant can be taken by simply measuring the length and the angle of the resulting vector. The first graphical mode is the parallelogram method. This is limited to two vectors, so you would need to work on two vectors at a time. Its principle is placing all the tails together and heads spread out. Then, you're going to reflect the vectors on the other ends to form a parallelogram. The resulting vector is taken from the point of tails to the point of the reflected heads. The Polygon method can be used with multiple vectors. It uses the concept of head to tail. So, the procedure starts with drawing the first vector and then connecting the other succeeding vectors to the head, whereby the resultant is identified by drawing a vector from the origin to the last head. Again, magnitude and direction are scaled. Algebraic method works with computation, so there is no need to scale drawing for this case. The triangle rule works with two vectors only, but it also follows the head-to-tail concept. So first vector will be placed onto the origin, followed by the second vector, which would create a triangle when resultant is placed. The magnitude and inclination of the resultant can be computed by using trigonometric functions like the cosine law and the sine law. Another algebraic method is the component method. This is a versatile way to solve multiple vectors algebraically. Because of the idea that we can only add or subtract collinear vectors, the concept of the component method is to break down vectors into its parts with reference to an axis. In most cases, a vector with a specific inclination theta is broken down to its x and y components, designated as horizontal component and vertical component. By using the elements of a triangle, the component can be known. For angles referred from the x-axis, the x component will be solved as the vector multiplied by cosine of the angle. Its vertical component is taken as the vector times sine of its angle. When the angle is referred from the y-axis, the component x will be interchanged to the vector by sine of the angle, and the vertical component will turn to vector multiplied by the cosine of the angle. After getting the components, you can solve the resultant by employing the principles of trigonometry. Having the two sides known, use Pythagorean theorem to solve for the resultant vector's magnitude. That is, r is the root of the squares of x and y components. The inclination of the resultant theta can be computed knowing that its tangent uses both components. By manipulation, theta is the inverse tangent of f sub y over f sub x. Check the next module on 3D vectors and the multiplication operations with vectors.